In this video, we are going to talk about some exponent rules, and in this video, we're going to just talk about product rules. So what is the product rule? The product rule says to multiply like bases, meaning bases that are the same, so same number for the base. We're going to keep the base, and we are going to add the exponents. So that's the important part. Keep the base, add the exponents. So in this example, our base is x, and you'll notice how we keep that x. And then what we are doing is we are adding our exponents. So if I have the exponent of m and m, then I add those exponents together. So let me show you an example. On example 1, our base is x. So we have like bases. So I am going to keep the base of x. And then I'm going to add my exponents of 2 plus 3. What is 2 plus 3? 5. So my answer is x raised to the 5th power. So let's see why this works. X squared, let me grab a different color here. X squared means that I have x times x. X cubed, or x to the 3rd power, means that I have x times x times x. So let's see, how many x's total do I have? 1, 2, 3, 4, 5. So that's why this works. So whenever you're multiplying bases that are the same, you keep the base and you add the exponents. Let's try that again on example 2. What is my base on example 2? On example 2, our base is y, so we're going to keep our base of y, and we are going to add our exponents, 5 plus 8. What is 5 plus 8? 13. So my answer is going to be y raised to the 13th power. Now take a minute and notice how my exponents are small and up high. Here this 5 is higher than the x. Here this 13 is higher than the y. You do have to make that distinction. If you wrote the 5 lower and had x5, that would be multiplication, not exponents. So here, this 13 has to be written small and up higher than the y. If we look at example 3, we have a base of a. So I'm going to keep that base of a. And we want to add our exponents. Here my exponent is 6. This a has an invisible exponent of 1. So when I'm adding my exponents, it's going to be 6 plus 1. Think about it this way. If this was a 0, then a to the 0th power is 1. And that's a rule that we're going to learn later. That anything raised to the 0th power is 1. So if this was 0, this a wouldn't be here. So whenever you have a variable with no exponent, it's an invisible 1. Just like how there's an invisible 1 for a coefficient right here. So 6 plus 1 is going to give me 7. So my answer is going to be a raised to the 7th power. If we look at number 4, what is my base on example 4? On example 4, my base is 3. My exponents are 2 and 5. So I'm going to do 2 plus 5. And when I simplify that, that's going to give me 3 to the 7th power. Now, if you look at examples 1, 2, and 3, our bases were all variables. On example 4, my base is a number. So I can evaluate this expression. I can find out what 3 to the 7th power equals. So if I open up a calculator, I'm going to do 3 raised to the 7th power, and I get 2,187. 2,187 as my answer. On example 5, what is my base? On example 5, my base is 2. My exponents are 4 and 4, so I'm going to add those. So this is going to give me 2 to the 8th power. My base is a number, so I can calculate and evaluate this. 2 raised to the 8th power is 256. On example 6, what is my base? 5. So I'm going to keep that base of 5. My exponents are 4 and 1. 4 plus 1 is 5. So my answer is going to be 5 raised to the 5th power. Because my base is a number, I can evaluate that and get 3,125. So that is how you use the product rule.